Okay, so we're going to Delta Math and we're going to go to just log in, and to switch to a new teacher or to switch to a new course for second trimester, we're going to go to Tools, Manage, Login, and Courses. And then on the bottom one, there's an Edit button. And all you have to do is hit the drop down button and then select. For us, we have third hour pre-calculus, Mr. Strub, second trimester. Please make sure that it's the second trimester one. And you could delete the other one. I'm going to actually archive that. And then once you're done, you should be good. And if you go to Delta Math, you should then see the assignment for tonight. All right. So I can kind of do a quick check to see who did or did not do that. And I will do that in a brief moment just to make sure everybody had a chance to log in successfully. Okay, so I think I'm going to put this slide down by actually I might even have it down there. No, I don't. I'm going to put this slide down at the end in case some of you did not get a chance to change this yet. Don't get scared by the amount of slides either. It goes pretty quick. So we need to have a quick discussion about the expectations for this trimester. And I want to make sure that you are all well aware of what I expect from you and what I'm going to be checking for, and a couple of small changes to this trimester. So to start, we are covering 3 chapters, and we're going to cover chapter 3, 4, and 5 out of our textbook, which I know you guys don't really have a textbook, which is fine because we use Delta Math for almost everything. I just want to show you the titles quick. Exponential functions and logarithms. We've done exponential functions before, so I'm going to go pretty quick today, assuming that you have that background knowledge from Algebra 1 and Algebra 2. When we get into logarithms, we're going to slow down a little bit because you have not seen logarithms yet. So this will be a completely brand new concept. Chapter 4 is going to bring back some pieces from geometry and Algebra 2 with trigonometry, SOHCAHTOA, and then we're going to add in more pieces of SOHCAHTOA. And then for chapter 5, we get into the analytic side of trigonometry, which is basically how do we solve functions? How do we use algebraic concepts to help do trigonometry in a little bit different? So chapter 5 will be almost completely brand new. Chapter 4 will be mostly new. But the part I want to really hit home right now is if you're going to take calculus next year, it is 100% assumed that you have mastered these skills going into calculus. So I really want you to understand that for this trimester, we are setting the foundations so you can do well in calculus. All right, now this is just some observations that I had from first trimester. More will come up throughout the year, but I just want to let you know about this ahead of time. So if I look back and just compared our grades, the students who did not get behind on their homework did very, very well. The ones that were always working through Delta Math, they didn't do poorly on the tests because the tests were basically based off of the homework, almost identical. Keep in mind, any test that we do goes into the summative category, and that's 50% of your overall grade. And the homework and quizzes are 50% of your overall grade, which means if you don't do the homework, that can really, really drag you down. And if you're not doing well on the tests, that will drag you down even faster. So homework is extremely important, more than it's been emphasized in years past. My office hours, all right, I'll show you that where they're at in a second, but everyone is encouraged. When we did the survey at the end of the last trimester, students were saying, well, I didn't go to your office hours because I didn't want to annoy you, or I didn't want to take up anybody else's time. That's why I have my office hours. I usually just sit on Zoom from 1 to 2 o'clock waiting for students to join in. Now, I might be doing work during that time, but the second a student joins in, I'm right there to help you. Full engagement. Every once in a while, it gets busy, especially after conferences, it got really busy. So there might be times where you might have to wait, but that's super rare. I would say on a given week, I probably have 4 students that join me on my office hours. So I'll show you where they are and when they are in a second. This is big. If you are having an issue submitting work to Schoology, okay, if you are submitting images that I can't see, they're blurry, it's too dark in your room, or you can't, you're taking a picture with your iPhone and you didn't turn off the live photo feature. If you're having those issues, you need to stop into my office hours and we need to figure that out. I am not going to accept any images that are not clear. Or if I can't open it, that means I can't see it, and it's a 0. And I might put a comment in the Schoology gradebook saying, hey, I couldn't see the image, resubmit it, but I'm not going to go above and beyond. You should know how to submit work to Schoology. And if you don't, I'll show you a resource, but if not, stop into my office hours. All right, a couple of big items here is when we show work on tests. I'll remind you again before we take our tests, but you need to show work for every problem, unless it's a problem that definitely requires no work. But that work should also match the work that we teach in class. What I've noticed is that students are using some alternative source. It might be PhotoMath, it might be some other version of getting answers, and they're submitting that, and then I'm looking back at their work, and their work is a higher level mathematics that we've never taught. I'm not saying it's wrong because it's right, but I'm questioning the authenticity of your work. Where are you getting that work from? And if any of that raises a red flag, then I'm going to have a conversation with you and talk about the academic integrity. All right, so that's the next slide. And then the class expectations for Zoom attendance is going to be marked throughout the hour. It's not just because you logged in once. So if I do a Zoom chat or a poll, or if we end class early and you're sitting on Zoom and not responding to me, I'm going to go back and mark you absent, meaning you should be engaged for the entire length of Zoom. If you fall asleep or you're distracted or you're on your phone, that's not the expectations we have of being present in school, okay? All right, so the big piece here I want to make sure everyone is aware of is the academic integrity. Now, we have finally got some language around that for the start of this trimester. So what happens if you aren't doing honest work? If you're sharing your answers, you're using some outside source to produce an answer, there are consequences that go along with it. And here it is. So if I notice that a student isn't doing their work, what I'm going to do is I'm going to report that to our administration. I'll document it. Students are given the opportunity to do a reassignment or an alternate assignment for only 50% of the credit. So if you get caught doing some extra, something that isn't authentic work, if you're not using your own work, that means you only earn 50% of that credit. And you still have to do the work for that test or whatever assignment is. And then the teacher will notify the admin, the parents, and document it. And then the admin also documents that in their behavior tab. So it kind of goes on your record. Now, what happens if it happens again? So if that happens again, then the student receives a 0 and cannot make up that assignment. The teacher notifies the grade level admin. The admin coordinates a conference with parents, students, and the administration, and the teacher may or may not be included depending on the time. If it happens a third time, now this could also happen with homework. If you're using somebody else's work and I end up finding out, that's a form of academic integrity. Okay, so if it happens a third time, you may be dropped from the class, or you may have some other consequence determined by the admin. So I do want you to understand the importance of doing your own work. This is an elective course. It's pre-calculus. It's meant to set you guys up for success and lay the foundation so you are ready for calculus. Now, it is an elective course, which means it's not required for high school graduation. So if some of you are treating this as I'm just going to kind of team up with my buddies, or I'm going to use the internet to solve some of these problems, then you are in grave danger of not doing well. Okay, so for those of you that just joined us, I'm going to actually have you go back and watch the first 10 minutes of the video at the end of the hour once it's posted, because we talked about observations, expectations, and academic integrity, and it's important that you understand what is at stake. All right, expectations for class. Be on time. If you're showing up 10 to 15 minutes late, you're missing out on important things. And if we're all 5 to 10 minutes late, that's slowing down what we have to get done for the day. Attendance, attend class for the entire 75 minutes. Always, always, always read the agenda and complete the required tasks. And then this is meant for me, but I'm going to show you our Schoology page here. So what are the expectations for you? If you start class, okay, you have to go to pre-calculus and then get my 3rd hour link. It's right there. It's the fourth one down. But you should also click on week 1 or whatever week we're in and then read the agenda. All right, what are we doing today? Well, what we're doing here is updating Delta Math account. There's going to be a video below. So that's what I'm recording now. And then we are doing class notes, and then we have homework tonight. And then look at Wednesday, the expectations for Wednesday. Now, this will change as the week goes on, because sometimes we don't get done what we need to get done on Monday, and that changes the whole week. But if you have, if you click on the Monday link, here's the same agenda, here's the notes that are filled out for today, here's where you submit the homework, here's a video how to update your Delta Math account, and then here's the video for class today. So if you miss it for some reason, you can go back and watch it. But what I'm seeing is Wednesdays, some students are treating Wednesdays as optional, and that's not true. You need to log in, click on the Wednesday folder. Now, I didn't update this yet because I'm not really sure how far we'll get today. But on Wednesday, when you click on that, there will be an agenda, and you need to follow that step by step for all of your classes. Okay? And the other thing you should always do is check your messages. I try to, when we have something new or a change, I send an email or a message through Schoology. So because you don't check or don't read that, that's on you, that's not on the teacher. All right, so those are the expectations of class. What we're going to do is we're going to introduce the idea of logarithms and, in this case, exponential functions. And we're going to look at solving exponential functions here and how we set them up. Like I said earlier, this is basically a big review, and you should be hopefully really comfortable with today's lesson. All right, so we're going to take a little bit of notes, but we're not going to write all of these slides down. I just want you to be aware there's a good amount of slides. But I want you to write this one down and title it Chapter 3, Section 3.1. We'll go over this in just a second. I'm just logging attendance. Okay, so the big goal today is for us to kind of go through and get refamiliarized with this function right here. Now remember, we could put y equals or we could put f of x equals. It doesn't really matter. But we're looking at exponential functions. Now there's two types of exponential functions. Exponential growth, ones that grow quickly, or exponential decay, and then ones that start getting smaller and smaller and smaller as time goes on. Now, this function really lends itself to real world problems. And a lot of times you see this in like the decay problem would be you have a radioactive substance and it has a half-life and it keeps the amount of substance cuts in half every minute. So then you can see that the curve keeps getting lower, lower, and lower. Or we have something like exponential growth, and unfortunately, we are seeing a very, I don't want to say wonderful because it's not, but if you think of it mathematically, we are seeing a very, very, very exponential model in our everyday lives right now with coronavirus, right? The spread of the coronavirus is growing, growing, and growing exponentially, meaning it gets bigger and bigger and bigger. And as much as I wouldn't want to use that as an example in class because it's really personal right now, I think you guys can understand that how that model works and see how you could use an exponential function to model that growth, which could help us make predictions. And that's why you see so much information centered around the data that comes out every 2 weeks, and that determines if we're hybrid or distance learning, and even the what the government has, or the governor has put in place with the restrictions that we have. They're using the data based off of an exponential growth model that if we predict this, it's going to keep growing and growing until it's out of our control. So anyways, how do we actually determine if it's growth or decay? And there's a couple things we need to look at. So first thing is this A value is your initial value. It's kind of like your starting amount of money if you put it into a bank account, or the amount of people who might be infected with a virus. That's at the start of the time, right? You usually start with like one person, and then that spreads to 2 and 3 and 4 and then 8 and 12 and 16, and it just keeps growing and growing and growing. So A is the initial value, but what we're really interested in is this B value. The B value is kind of the exponent's base, or it's the base. So I like to think of it as B stands for base. But if you take the base and minus the growth factor, that gives you the rate of decay or the rate of growth. Now, how do we know based off of that number if B is between 0 and 1, meaning it's a decimal or a fraction less than 1, then it's going to be a decay function because you're taking a like 75% of a population or 75% of an amount. You're cutting that by a factor less than 1. If B is greater than 1, then your growth is going to be more than 100%. So that means your whatever we're looking at is going to grow and grow and grow. So we'll look at that, and hopefully you'll be really comfortable with that. We are going to analyze this a little bit more and break it down into how do we determine a rate versus just a growth factor. Notice a couple things. Your initial value cannot be 0. You can't start with $0 and then all of a sudden gain more money over time, because you have to have an initial amount that's more than 0 for it to be able to grow. Your B value has to be something larger than 0, right? So we don't put a negative value in there. And then B can't be 1. If B is 1, that means you're not growing at all, because 1 to the power of anything is really just, it's always going to be 1, so that means you're going to have a straight line. All right, so hopefully you're familiar with this. Our goal today is to analyze functions and look at the behavior to kind of do some quick solving and interpret some word problems. Okay, so we just kind of quickly showed you that you can still calculate y-intercepts by just plugging in x equals 0. And then we showed you that there actually is no x-intercept with this specific problem, because there are horizontal asymptotes at y equals 0, which means this graph will never cross the x-axis. Okay, I do want you to write this slide here. So I'm going to give you a second just to copy it down, and then see if you can identify domain, range, continuity, symmetry, boundedness, and we actually kind of already talked about the asymptotes, but I just kind of want you to take what we learned from last trimester and apply that to this graph of the function 2 to the power of x. All right, let's go over this quick. We're going to kind of break down the characteristics of the graph first, and then I actually want to talk about how do we produce this graph when we have a table, because dealing with exponents is a great review with how do we deal with negative exponents. But let's start with domain. So domain are my x values. That's anything from left to right on the graph. Well, notice this is a continuous function all the way from the left to the right, which means my domain ends up being all real numbers. And we want to write that with open brackets from negative infinity to infinity. Now the range is a little bit different, and the reason why the range is different is because of that asymptote that we talked about before. We have an asymptote right here at x equals 0, or excuse me, y equals 0. The graph is above that. It's never going to cross this line, so that means that my range is actually going to start just above 0, so we're going to have an open bracket at 0, and then we're going to go all the way to infinity. All right, now continuity. Where is this continuous? There are no breaks, gaps, or discontinuity here, so it's actually continuous for the entire function from negative infinity to positive infinity. All right, symmetry. We have the odd or even symmetry from before. Since I can't reflect this, if I had a point on this side, it doesn't reflect over to the left side, so I cannot reflect it over the y-axis, which means it is not an even function. If I was to take a point here and rotate it 180 degrees, it doesn't produce kind of that same graph, so it is not an odd function, and in this case, it is neither odd or even. So in this case, we would say there is no symmetry, or you could just say none. Bounded. Is it bounded above or below? In this case, because there's an asymptote that kind of blocks off this bottom part, it is bounded below. All right, asymptotes we already talked about. That's the red line. That is the horizontal asymptote at the equation y equals 0. Now you should also be very conscious of, if we say, is there an asymptote, you should be able to write the equation of where it is. Okay, this is the y value 0. That is the asymptote. What do we do for y-intercepts? Well, y-intercepts are whenever the x value is equal to 0. And we did that on the last example. So what happens, actually I'm going to use function notation. What happens if I take my equation, f of x, but in this case I put in 0. So what is f of 0? Now it's not 0. 2 to the 0 power is 1. So that means the y-intercept is at the point 0, 1. Okay. And then x-intercept. The x-intercept is whenever the y value is equal to 0. So what happens if I make the function f of x equal to 0? Now we don't officially know this yet, but there is no way right now for us to solve this. And there's no value for x that I can take 2 to whatever power and make it equal to 0. So in this case, it does not exist. Or we can just say none. There is no x-intercept because we can't solve this. So those are things that we expect you to know. Even though it's a new function, you should still be able to identify all those pieces. Now here's the important part I want to show you, and it's up to you if you want to write the table or not. But without a calculator, could we get a graph of this if I knew the function? Well, yeah, we just make a table. Pick negatives, pick 0, pick some positives. So what happens then when I plug in -2 in for x? We get f of -2. And then here's the big piece. You should know what the negative exponent does. Now, I'm going to show a little more extra work here, but the negative takes the base and puts it in the denominator. So now instead of 2 to the negative second power, it's 1 over 2 to the positive second power, which is 1/4. So if I go over 2, you can see I went up a quarter, 1/4. Well, same thing here. What if I do -1? Right? That negative exponent is going to put it in the denominator and make it a positive power. So now it's 1 over 2 to the first power, or 1/2. So if I go over 1 up a half, you can see the points starting to take shape. Now we already did this one. I'm going to just make it really quick. We already did f of 0, which was 2 to the 0 power. Anything to the 0 power will always be 1. I have to put a 1/2. Right? And then the rest of these are really friendly. If I do 2 to the first power, that's 2. If I do 2 squared, that's 4. But look at, we're growing, and this is actually called a doubling function because the base is 2. So every unit of x, we're doubling the value. And that's why our growth is going up. Now notice, why is this a growth function? More than just it's going up, look at the base. The base is larger than 1. And that's the work we want to get to today. So hopefully it's a good review of negative exponents. I can tell you in calculus, some of my kids really struggle with this at the beginning of the year. Just the negative exponents. All right. So we're going to go through a couple of problems here that I don't want you to write down. I'm going to be posting these notes to Schoology, so if you need to go back and look at them. But the goal is to just kind of cruise through some of these problems so you guys can get a good feel for it. Okay, actually, you know what? I forgot about this slide. Depending on how comfortable you are with this, you may want to really write this down. And then everything else after this is probably you don't have to write down. So what did we talk about today? We talked about we have an exponential growth or decay function, and we can tell if it's growth or decay based off of the b value. A is your initial amount. Well, and then x is kind of like your input variable, which is really the same thing as time if we're applying a word problem to it. So there is a connection to interest formulas, and you hopefully are really familiar with this. But I could take the exponential growth or decay model and make some substitutions. So instead of A, we can call A the initial amount. So we're going to call it P sub 0. That's the same thing. That's your initial amount. And then your B value is really 1 plus a rate. Now this is the interesting piece. The 1 plus the rate is called the growth or decay factor. Right? And then you most likely are going to have to do a little bit of work to figure out what is the growth or decay rate. So what is just R? Now it's not going to be set up as 1 plus R. It's going to be 1 plus whatever the rate, and then you have to undo. So you'll basically be solving for R. All right, and then T is always going to represent time. All right, so notice T is your input variable. T is the same as X. Okay, so now we basically can look at this as identifying either the growth or decay exponential function or relate it to specific content, and that's what we're doing today. So I'm going to jump to this piece. Now here's where I don't want you to write this down. I'm actually going to do the first two problems together, or I'm going to do these two, and then I'll have you do the last two, just so you can kind of see how this works. And some students like to have this written out. So what was it? It was your initial amount, p sub 0, and then 1 plus the rate times the time. So this is the equation that we're comparing it to. And they're going to ask you a couple of different things. Just from the equation, let's analyze right away, what does it tell me? So first thing I'm going to look at, easiest thing to decide, is what's the initial value? Well, the initial value for both of these problems is the value that's in the A position, or the p sub 0. So think of this as if it was like a bank account or maybe a population. We started with $3, or maybe it's 3 people, right? And in this case, we started with $1,335. Okay. Now, then we have to look at the growth factor, and that's the 1 plus r. That's whatever's in the parentheses is my growth factor. So that's pretty quick and pretty easy to identify. The growth factor here is 1.2. Now, let's think about that. Since the growth factor is larger than 1, that tells me that this is an exponential growth model. So you can tell right away if it's growth or decay, right? Just from the growth factor. So because it's greater than 1, exponential growth. But look at this one. This is less than 1, 0.9998, which means this is going to be the exponential decay model, because it's less than 1. All right, and then the part that the kids kind of usually make an error on is, remember, if I want to find the rate, the growth factor was made up of 1 plus the rate. So if I know what the growth factor is, all I have to do is say, okay, how did I get 1.2? That was made from 1 plus r. So if I subtract 1 from both sides, I get 0.2. Now, what we want to do is we want to move this to a percentage. They usually want this as a percent. So we're just going to do that every time. So what is that? 0.2 is 20%. We just move the decimal spot 2 spots to the right. So that means that if this was a bank account and I put $3 in and I got a 20% interest rate, this would be the equation I could use to figure out how much money I would have after X amount of years. Well, now notice how this one is a little bit different. Because this is a decay factor, that means that at some point I'm going to have a negative rate because things are going down. So if I subtract 1 here from both sides, I end up with 0.002. But now that's a decimal. I want that as a percent, so I got to move this 2 spots to the right. So I end up with 0.2. Sorry, my pen just screwed up. 0.2%, which is completely fine. Or you put 0.2%. All right. So now notice this officially is decay. And I have to be really careful because if my rate, and actually it should be a negative because I'm subtracting 1, which is larger than that. And now notice, because the rate is negative, that's going to produce an exponential decay. All right, so what I'd like you to do, and this is up to you if you want to actually like physically write this down or just think about it, but let's take these two problems. And I'd like you to go ahead and All right, so let's go over this really quick. My initial value is always the A value. So in this case, it's 341 and 5.3. My growth factor is always the entire decimal or whole number, but it's the entire base. Now notice this number is less than 1. So right away, I would know that this is exponential decay because the base is less than 1. So on this example, you can see that the base is greater than 1. So this would be exponential growth. And then to actually find the rate, you take your growth factor and you set it equal to 1 plus r. And then you always subtract 1. You don't have to show this work. You could literally just grab your calculator. But then we do have to remember to turn it into a percentage. So here, we would say, now we have to be careful here because officially this is negative 90.7%. That's kind of what we're going down by each time. So if I'm saying this, I would really call this a decay rate. And then if I call it decay, I don't need the negative right there because the word decay implies that this is going down. So you just have to be really careful with if you put a negative here or not. All right, and it's mostly when you're answering kind of like that word problem. So for the next one, we know it's exponential growth, but we can confirm that by taking this answer and subtracting 1, and then moving our decimal spot 2 spots to the right to get 1.3%. So I have a growth rate of 1.3%. All right, so hopefully that's all Algebra 1 stuff. I hope you're really familiar with that. The next couple slides here, I don't want you to write down. We got a good amount of them. I just want to give you some exposure to the problems. I feel like we wrote enough down, and these notes will be online if you want to watch them back at any point. So let's go through this kind of quick. And here's where kids kind of struggle, though. All right, there is another type of formula that is called compounded continuously. And that's when you have a special base E. It's called the Pert Formula. And I believe you're familiar with that. If not, we'll review it here quick. Well, let's just kind of read this problem and use the Pert Formula. And notice they give it to us to help us solve this problem. So let's look at this. A person places $479 in an investment account. That's the initial amount right there. You know how much you started with, so that's your A value. But in this case, the P is in the spot of the A, so that's your initial amount. And then you have you're investing in an account earning an annual interest rate of 8.2%. So we have to be really careful here. I'm not going to put R as 8.2%. I have to convert that to a decimal first. And that's the one thing students always kind of forget is, okay, if this is 8.2%, I got to move the decimal back 2 spots to the left. So now I got 0.082. And that is the R value. That's the R value that we're looking for right here. All right, and then this is compounded continuously. When you see the words compounded continuously, that tells you that the base is E. All right, and then V is the value of the account in T years. P is the principal initially invested. E is the base of the annual logarithm. R is the rate of interest. Determine the amount of money to the nearest cent in the account after 12 years. So now they basically are asking us, how much money do we have after 12 years? Well, V is the initial, or that's your amount of money, the value. And then P, we know, is 479. E to the power of the rate, which is 0.082, times the initial, or excuse me, the amount of years that we're going to hold this money in the account. So what I would like you to do is grab your calculator right now. And once you write this out, then everything else is just plug it into your calculator. I'm going to show you how I would do this as soon as I get my calculator up. All right, so give me 1 second. This is just a calculator simulator. Okay, so I'm just going to go to a blank screen. I'm going to type in 479, my initial amount, and then I have to get the base E. And that is the ln button, but it's the blue part, so it's the second function. Second ln is base E. You can't just type E in. You have to use the base E. And then notice how it gives you parentheses, or it gives you an exponent. I always recommend putting parentheses, and we have to do 0.08 or 0.082, and then I just am going to put times 12. But notice how I started and ended with parentheses. You want to make sure you do that, especially if you have a TI-83 calculator. And then just hit enter. And that will give us the value that we need. Now notice they did say round to the nearest cent, so then you have to be aware of proper rounding. The nearest cent would be right here, but the 9 would make the 8 round up. So after 12 years, my initial investment of $479 would turn into $1,281.39 or 39 cents. Okay, so you didn't need to write that, but it's just a quick review. We're going to go through these problems even faster. Okay, so in this case, you'll notice one thing. In an element with a mass of 590 degrees, or not degrees, sorry, with a mass of 590 grams and a decay. So decay tells us something special. Decay by 19.5% per minute, how much of the element is remaining after 15 minutes. And then round to the nearest tenth of a gram. So they do not use the words compounded continuously, which means I now have to go back to that original formula that we talked about before, which was y equals p sub 0 and 1 plus r to the power of t. And then it's really quick. And again, you're not writing this down, so we're going to go white fast. The only thing I want to show you is notice this is 1, 2. We got to move the decimal spot to get it out of a percent, but I have to be very careful. If I leave it like this, I ignore the word decay because decay means it's a negative rate. So I'm going to make that a minus. Some people do this when they see the word decay, they change it to 1 minus r, which I kind of like. Because that would be what it looks like for a decay. And then if you set this up, you don't have to do this, but I want to show you it anyways. If I use my calculator to solve this, but the very first thing I did was just subtract the inside piece, notice it gives me the growth factor. In this case, the growth factor is less than 1, which confirms that it's decay. So once I get to this point, then I would just type it into my calculator. And there's nothing special about this. 22.79, we're going to round to the nearest tenth. And then we want to make sure we identify the correct units. Which is grams. Okay. So that's the first part of what you're going to do today. Then we've got a couple other pieces. We're going to skip this one. Population has 1,000, grows to a percent. No, yeah, you know what? I'm just going to do it real quick. If I was to write this out, population of 10,000 people, it grows. Now there's the key word. It grows at a rate. Well, where's the decimal? It's here, 5%. I'm going to move it 2 spots. So that's what the rate is. So it would be 1 plus 0.5. Why is it a plus? Because we're growing. And then what would it be after 5 years? So basically, if I add the 1 plus the 0.5, and then I take it to 5 years, and now notice, we're talking about population. So I have a 0.8. That 0.8 is going to actually round it up to the nearest person. Right? So in this case, we're rounding to the nearest whole number. Okay, these are the ones that I want to show you, and I think we got a couple more. But this is another part of your Delta Math homework. And this is the part where it actually has you break down things. We have to be very careful with one piece. So that's why we're going to do just a couple of these quick. It's up to you if you want to write this down. I don't think you really need to, but let's look. Now they give us a function that represents the change in quantity over t days. What does the constant 0.997 reveal about the rate of change? Well, all right, let's look at that. We're going to look at this value right here. That's your b value. Well, when your base is less than 1, you have to do a couple of things to solve this problem correctly. There's going to be a drop-down menu, and it's going to be growth or decay. In this case, it's decay because the b value is between 0 and 1. And then what is the rate? Well, we've done that already. How did we get that? It was 1 plus r that gave us that answer. So then I'm just going to subtract 1. Which is negative 0.003. But notice, they want that answer as a percent. So now I got to move it back to a percentage. And here's the part where you have to be careful. Okay? The answer I got was negative 0.3%. But we used the word decay. Since we use the word decay, then we're only putting the percent as a positive value here. If you were to put a negative, I'm really curious if they would give you the credit if you said growth and then put a negative. But you can't put decay and have a negative here. That's like a double negative, and we don't want that. Okay? All right, and here's the tricky part. Every what? Well, here we're trying to look for, is it every minute, every day? But we actually have to calculate the value. Now, notice there's a 24 here. We didn't have that 24 in any of our other pieces. So this 24, we always want it to represent 1 day. Okay? So what's that mean? We have to basically find what t is. Right? Well, what is t? In this case, I have to just divide by 24. So that means that we are 1/24th of a day. So then you're going to have to look for what does the option say, but it's basically going to be something like this, 1/24th of a day. And I'm trying to remember if they have units on it or they just say like 1/24th day. Okay, so let's look at another one just so you're comfortable. Hopefully you can kind of look at this really quick. This is the same style of problem. They're saying, here's the function. It represents a change of quantity over seconds this year time. So now time represents seconds. What does the constant reveal? Well, we're looking at the base. Notice that base is less than 0. So this would be called a decay function. To find the rate, it's 1 plus r gave me that rate. Then we're just going to subtract. And when I do that, I get negative 0.05. And then I just move this 2 spots to the right. So I get a negative 5%. However, because we use the word decay, we're only recording the percentage. So it's positive there, even though when I did the work, it came out as negative, but we put the word decay for negative. So that's nothing special. But the special part is what are the units? So what do I need? I need to take whatever is in the exponent, and we always want that to be equal to 1 day, or in this case, 1 second, which means I got to solve. So I've got 60 divided by t. If I times both sides by 60, I get 60 seconds. So that means that the function is decaying exponentially at a rate of 5 percentage points, or 5% every 60 seconds. Now here's the case where they might say 60 seconds right here, or isn't 60 seconds just a minute? Right? So you have to really kind of read through that. If they say every 30 days, they might have the word month here instead of 30 days. All right, last one, I want you to try this. You don't have to write it down, but just what would the blanks be? And I'll give you a minute to think about this one. All right, let's take a look at it. So what do we have? We've got a function. We know the initial amount. We know the growth factor. And it's less than 1, so it's decay. And then because it's decay, that means we had to solve for r, which was negative 0.9, but we got to move that to a decimal, or from a decimal to a percent. So I get negative 9%. However, we use the word decay, so we're just saying that this function is decaying. It actually might say the word decaying exponentially at a rate of 9% every what? Well, now I got to look at the variable in the exponent. It's just t. So in this case, t is going to represent 1, and then the units for this problem is month. We don't have to solve anything here, so it's just every month. So we're decaying 9% every month. And that's what we want you to think about when you're doing these problems. Okay, I talked about this at the beginning of the hour. I'm going to post this slide up again in a second, but some of you joined a little later for different reasons. You will have to change your Delta account in order to access the homework tonight. So I'm going to come back to this slide in just a second. And I was hoping to do individual breakout rooms right now to speak to a couple of you, and we don't have that time. I might do that on Thursday. But here's basically what I want to say. This is the start of a new trimester. You have complete control over the amount of effort you put into showing up to class on time, being actively engaged, doing the homework on time, and attending office hours. Everyone is welcome to attend my office hours. They are, just so you are aware, you go to our pre-calculus slide. Here's a link for my office hours. It's the third link down, and it says office hours, Monday, Tuesday, Thursday, Friday from 1 to 2 o'clock. Everyone is welcome. If you have a question, stop in and ask for help. And then here's the link. I don't think you need the password, but the password is Strub with a capital S if you do. But I'll be on there today. If you want to stop in and have a conversation, we could talk about what worked well last trimester for you and what didn't, and what things should change. If you feel like you are not going to take this class this trimester, can you privately message me right now in the chat and just say, Strub, I think I'm going to drop. I need to kind of have that for my records. And then you have to reach out to your guidance counselor this week. Do not wait. If you wait too long, then they won't allow you to drop it. And then you have to go through the whole trimester. Or if you just don't do anything, then you end up with the no credit. So please let me know if you have plans to drop it and you have not messaged your counselor yet, and then talk to them individually. Okay, so what is the homework tonight? The homework tonight is pre-calculus 3.1, and we went through all the types of problems, so you don't really need to watch any videos or anything. And the homework is due tonight, so hopefully you're going to work on this right after lunch. All right, I'm going to post this slide right here again. So those of you that need to, you can go to Delta Math right now, select the tools, which is in the upper right-hand corner, manage login courses, and then the bottom part of the screen says edit, and you just need to reselect third hour pre-calculus trimester 2 course. If you don't do that, you won't have the homework for tonight. Okay? Everyone else, you are free to leave. Have a great day. We'll see you on Thursday. Freddie or Natalia, you got any questions?
No, thanks. I'm good.
All right, have a good one. I'm going to jump off. Get any questions, I'll be available in my Zoom hours 1 to 2.